Within our observable universe, there are approximately 70 sextillion stars, and of the order of 10 million billion planets around them. The unfathomable scale of this celestial ocean transcends human comprehension. Our terraqueous home barely registers as an imperceptible blip on a cosmic canvas. Since the dawn of astronomy, we've looked up at these oases of light and wondered if anyone else inhabits the dark with us, whether we're on the precipice of joining some galactic club of civilizations, or whether, maybe, just maybe, this is it, we're alone. When I talk to the public about astronomy and this question of life elsewhere in the universe, the most commonly held viewpoint I encounter is, surely it's impossible that we could be alone in the universe. After all, how could it be amongst this unimaginable number of opportunities for life to get going? It only happened once, only here. And this is a viewpoint held by many scientists and talking heads in popular media too.
Do you think that there is life outside of Earth, intelligent life in the universe?
Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming. There's 200 billion stars in this galaxy. Well, now it looks like every star has about 10 planets. So there's almost certainly intelligent life.
I assume it's the most frequently asked question, are we alone?
My best guess is that the universe is teeming with life.
There's surely other civilizations out there in the universe. There are 350 billion galaxies out there in the universe.
But an argument based solely on statistical grounds comes with a fatal flaw. And that is that it is perfectly plausible that the probability of life starting from scratch, which we call abiogenesis, is a number which is so small that it greatly outweighs the number of opportunities, the number of worlds out there in the universe for life to get going. For example, if the probability of life beginning is 1 in septillion, say, then the case for a crowded universe evaporates. In such a scenario, we were the only example of a success. And so we are simply unaware of just how unique, how special we truly are. Our anthropocentric bias clouds our view. This is precisely the point made by friend of the channel, Professor Sean Carroll, when he counters Elon Musk's more widely held view that life must be common. Let us make no mistake though, the vast numbers of stars, the discovery that planets are common, and that even potentially Earth-like planets are common, all of these points move the dial closer towards a crowded universe scenario. But critically, without knowing the probability of abiogenesis, we may simply be moving that dial from, say, 1 in octillion to 1 in septillion. And so crucially, the statistical argument can only really be made if we have 2 pieces of information in hand. We need both in order to complete our understanding. The number of habitable worlds out there, or potential seats for life more generally, and also the probability of life spontaneously emerging on those worlds. Astronomy has clearly made great inroads about one of these 2 pieces of information, but what does science tell us about the other? What is then the probability of life spontaneously beginning, the probability of abiogenesis? Assessing the probability of abiogenesis has proven to be incredibly elusive and challenging for modern science. Rather than speculating about this, let's focus here on what we know. and come at the problem from an observational perspective. Let's start with the fact that all life on Earth uses water to survive and is carbon-based. Two chemical ingredients which we certainly know to be common in the universe. What's more is that organic molecules such as benzene, urea, sugars, and even amino acids appear to naturally form even beyond the Earth, such as on interstellar dust grains, comets, and molecular clouds. So certainly the chemical ingredients which go into Earth-based life are found frequently across the cosmos. But that fact alone doesn't establish that life must be common in the universe, because it doesn't say anything about the probability of those chemicals coming together in just the right way to create a self-replicating chemical network capable of Darwinian evolution, a possible working definition for life. At a basic level, we certainly know that no lab experiment here on Earth has ever succeeded in creating what we would call life from chemical broths with conditions similar to that of the early Earth. This was first famously attempted by Stanley Miller and Harold Urey in 1952 at the University of Chicago. In what is now often considered the classic abiogenesis experiment, they exposed a beaker of water, methane, ammonia, and hydrogen to gentle heating and electrical sparks which emulated lightning. Now, many organic molecules were produced in this experiment, including 20 amino acids. But neither in that experiment, nor in any experiment since, have we observed the spontaneous production of complex proteins, nor DNA, nor indeed something crawling out of the test tube. The fact that we have not succeeded in creating life from scratch from these chemical broths, despite many attempts, demonstrates that at the very minimum, life is not an inevitable or even particularly likely outcome of just stuffing organic molecules together and waiting for a few days. These experiments may be flawed or simply not run for long enough yet, but it's also compatible with the hypothesis that the Earth really was exceptionally special. It had just the right conditions, or perhaps was extremely fortuitous that a specific set of chemical reactions occurred in the necessary sequence at the necessary times. And these ideas start to broach onto the famous rare earth hypothesis first posited by Ward and Brownlee in 2000. A common counterargument to this is that the proliferation of life on Earth across a very diverse range of environments surely implies that life is capable of surviving, indeed, in a broad array of conditions. In particular, life forms known as extremophiles, like the tardigrade for example, are able to survive in acid baths, boiling water, or even the vacuum of space. Surely this means that life would be easy. And indeed, this was precisely the line of argument Elon Musk threw back at Professor Carroll in their Twitter exchange. Now, whilst I agree with what Sean wrote in response to Elon, I think a more pressing concern with Elon's line of argument is that extremophiles are highly sophisticated organisms with advanced complex internal machinery to help them cope with these diverse range of conditions in which they inhabit. They are the product of billions of years of evolution. But the very first biological cell to emerge from muck could not have been equipped with this kind of advanced internal machinery. It would have been far simpler. And so the fact that life can adapt to extreme conditions does not speak to the question as to whether life can start in extreme conditions. Leaving extremophiles aside, another common argument I encounter in favor of a crowded universe scenario is that life appears to have begun quickly here on the Earth, and on the face of it, that appears like a good argument. Microfossil evidence and hypothesized biologically manufactured mineral deposits indeed indicate that life was active on the Earth soon after conditions became suitable for life, perhaps just a couple of 100 million years after the Earth's magma surface solidified. Surely, the early emergence of life on Earth demonstrates that life is a relatively easy process to get going, and thus we should expect a universe teeming with life, right? Actually, no. And this is a misinterpretation of that fact, which is very common even amongst scientists. This is really a question of statistics. And to understand where this flaw in the logic comes from, let's go through a thought experiment together. Let's imagine that I take 1 million people and I lock each of them inside a prison cell, 1 cell per person. Now, each person doesn't know about the others. From their perspective, they might be alone or they might be one of many. Each person is given 1 minute to pick the lock, else the occupant will be killed. And to be kind, let's give each person a hairpin to try and pick the lock and get out. So the timer starts and everyone starts trying to get out. But they have no idea how hard the lock really is. In fact, the lock can be picked, but it takes, on average, about 100 hours of random prodding before it will click open. Now, after the timer ends, as you can imagine, pretty much everyone is dead. Okay, I admit this is a pretty horrendously unethical experiment, but bear with me. Now, remarkably, not everyone died. 1 person did escape. Let's call him John. Now remember, John actually has no idea how many people were locked up and just tragically died. So imagine now walking up to John afterwards and saying, "Hey, you picked the lock, was it hard?" He'd say, "Oh, no way, it was easy. I actually picked it first time. I got through it in 5 seconds." From John's perspective, he only has 1 data point to work with, and that's himself. And from his perspective, it was a piece of cake to get through that lock. Now, if John were to learn of the other 999,999 dead cohabitants, he would surely reevaluate his position and realize that the lock is actually incredibly tough to break. But because he only knows of the winners, which is to say himself, then his only data point is telling him that the lock is easy. And of course, in the same way, let's now imagine that each prison cell is a planet, and each trapped prisoner is representing a chemical soup, if you will, trying to become alive in the limited time available whilst the planet is habitable. Well, we are John. Earth is the one that got through the lock, and from our perspective, it seemed quite easy because we got through it pretty fast. But what about everybody else? Well, we have no idea. Maybe the lock is easy, and there are countless inhabited worlds out there just waiting for us to find. Or maybe we are completely alone. No one else picks the lock. So clearly, we are missing a huge piece of information necessary to figure out the true answer. The fact that we picked the lock quickly doesn't actually matter because we may very well be a statistical outlier. In a scenario where the probability of abiogenesis is hard, then the time it takes for life to get going on planets where it does get going tends towards a uniform distribution. So in our prisoner analogy, repeating the experiment many times and asking all the survivors how long it took, you would find that their times would be uniformly distributed from nearly instantly up to the maximum time, 1 minute. This mathematical result was first pointed out by the economist Robin Hanson in 1998, and it's easy to prove analytically too, as was done so in our own paper on the subject recently, which I'm linking down below in the description. So if life is hard to get going, then because of this uniform tendency, an early start to life is just as likely as a late start to life. In fact, if you think about it, a late start to life is actually kind of prohibited, because if life had started on the Earth late, then there would have not yet been enough time for bipedal hominids such as ourselves to have evolved and start to ponder these kinds of deep questions. And thus, the fact that life started quickly here on Earth actually provides essentially no information about the probability of life being present elsewhere. Statistics flatly disagrees with our naive intuition. I think it's difficult to characterize just how counterintuitive this result truly is. Let's assume that you followed along with the statistical argument that I just laid out to you, and imagine that I knock on your door and I say to you, I'm going to force you to make a bet. You have to bet your life savings on either the fact that the universe is filled with life or that we are alone in the universe. Now, I think many of us, when we think about bets without any information to really guide us, we tend to lean on our gut instincts, onto our intuition. And I think many of us would probably choose the crowded universe scenario given that bet. But why do we do that? Why do we feel compelled to lean in that direction? Or maybe we have our own biases for thinking the universe is filled with life, or perhaps the other way around. But I think another powerful force is the principle of mediocrity. We tend to think that our experiences are typical, that the rules which are present here are similar to the rules which are present elsewhere. And that may very well be misguiding us when it comes to the question of life elsewhere in the universe.
What is faith? It is belief in the absence of evidence. Now, I don't propose to tell anybody what to believe, but for me, believing when there's no compelling evidence is a mistake. The idea is to withhold belief until there is compelling evidence.
I think when we broach this grandest of questions, I would say, as to whether we're alone in the universe, it's critical that we keep an open mind, because the present data is certainly compatible with plenty of life in the universe, but it's also fully compatible with us being completely alone in the universe. The ubiquity of planets and organic molecules is encouraging, but not merely enough to establish a living universe. The adaptability of extremophiles to a wide array of environments says nothing about the propensity of life to begin in such spaces. And the early emergence of life on Earth is fully compatible with a statistical fluke, that we really are alone. And I wouldn't say that that means we're necessarily somehow lucky. It's just out of trillions of attempts, there is plausibly one success. We are it. So what do I say when someone asks me, do you believe there is life elsewhere in the universe? Carl Sagan once famously wrote that faith is belief in the absence of evidence. And honestly, any scientist who says there has to be life out there is putting forward a position of faith, not one supported by observational evidence and statistical reasoning. The most intellectually honest answer to the question is, I don't know. It's rare to find these days, but we should not be afraid to state that most brutally honest and truthful of answers, which is that we simply do not know.
You see, one thing is I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong. I have approximate answers and possible beliefs and different degrees of certainty about different things, but I'm not absolutely sure of anything. And then many things I don't know anything about. But I don't have to know an answer. I don't feel frightened by not knowing things, by being lost in the mysterious universe without having any purpose, which is the way it really is, as far as I can tell, possibly. It doesn't frighten me.
Even though we don't know the answer to this question, it's interesting to consider the ramifications of both possibilities. Consider a collection of worlds. It could be a group of nearby stars, it could be our own Milky Way galaxy, or it could even be the entire universe. In this collection, let's say that there are n habitable worlds. If the probability of abiogenesis within a few billion years is 1 divided by n, then we should expect that we are the only example of life in that collection, and indeed that each example of such collections only has one example of life within it. But the probability of abiogenesis could be anything. I mean, anything from 1 divided by infinity, which is 0, to 1 divided by 1. The chance of it being tuned to precisely 1 divided by n, whatever kind of collection we're talking about, is somewhat unlikely in of itself. I mean, that's a very finely tuned, contrived state of affairs if it turned out to be true. Chances are, then, that the probability is either much larger or much smaller than 1 divided by n. Take the first case, where it's much larger. Then, within this collection, we are very likely not alone. In almost all examples of such collections, one finds a very large number of inhabited worlds, a crowded universe. What about the other case? What if the probability of abiogenesis is much smaller than 1 divided by n? Well, here, the chance of even a single collection having life in it is small. So, in fact, most collections are completely devoid of life, and thus we live in one of the rare examples where life succeeded. In this case, there is almost certainly no one else living in our collection apart from us, or indeed any nearby collections. And so putting these pieces together, you can see that it's fairly contrived for every galaxy to have just one inhabited planet in it. Either each galaxy has many, many examples of inhabited worlds within it, or it's actually very unusual for galaxies to have life in them at all, and the Milky Way is somewhat special and unique in that we live within it. On a multiverse scale, one can make the same argument. Either universes tend to be densely populated with life, or most universes, even those with the same laws of physics as ours, are empty, and we're in a very special one. To quote Arthur C. Clarke, both options are somewhat terrifying. Thanks to science fiction movies and books, we're pretty familiar with the concept of a crowded universe, one often filled with hostile aliens traversing space just to smack us over the head. And communicators like Carl Sagan and Frank Drake were eternal optimists who felt convinced that we were not alone. But a less familiar, a less popularized, and arguably a less attractive possibility, a very real possibility, is that we are alone, and that loneliness might be far starker than we even realize, for we may very well be the only inhabited world in the universe. Lost in the dark, a singular candle holding back the empty void of thoughtlessness. What a responsibility it is then to be alive. This one place, this one Earth, may be the diamond of the universe. You could travel for billions of light years, and all you'd ever see is countless numbers of lifeless worlds. And so every one of us here on Earth would be incredibly special. You, me, every person you bump into, every person you see, every person you've loved or hated in your life, every one of the billions of people living here on this planet would be incredibly special, incredibly rare, the diamonds of the universe.
But whatever way it comes out, its nature is there, and she's going to come out the way she is. And therefore, when we go to investigate it, we shouldn't pre-decide what it is we're trying to do, except to find out more about it.
Never let yourself be diverted by what you wish to believe, but look only